Hello, welcome back to the channel. In this video, we're going to be looking at a static keyword in Java. But before we do that, let's just take a quick look at a simple class. Right, as you can see, my class is called a superhero class. Now, if you've seen my last video about method overloading, you would know that this is familiar. This was the similar class that I used to explain method overloading. And this is also the idea or the class that I'll be using to explain the static keyword. But our class is currently empty. So let's just add a few variables and methods, right? What we often call attributes and behaviors. So let's just add a few attributes. And as you can see, we have a name, a power, and age. And you know what attributes are. These are characteristics for this idea of a superhero. And I could use this class to construct or to make a superhero, right? I would actually put in those values for name, power, and age. Now let's also add a few methods, right? Let's add a few setter and getter methods. Now first I need to add getter methods to display the name, to display the power, and to display the age. So let's add a few getter methods for that. And these would look something like this. So I have a get name method, which would return the name, a get power method, which would return the power, and a get age method that would return the age. And then we'll also add a couple of setter methods. Now you could also replace the setter methods with constructors, and it's way easier to do that. But for this particular example, I am going to be using setter methods. So setter methods to set the name, to set the power, and to set the age. Right, so now that we actually made our class, we're going to make objects using this class. And we know what an object is. An object is just an implementation of your class. So I made 3 objects using the superhero class. And as you can see, I have 3 different objects which are all just implementations of my original class. Now what's one thing peculiar you notice about these objects? The values of the variables name, power, and age, which are your attributes for your class, are different for all 3 objects. And you know that a variable can hold one single value. So how is name in this case George in one object, Jim in another object, and Teja in another object? It's not because of something like method overloading or variable overloading. It's because whenever you make an object, what you're storing is not those variables, it's a copy of those variables. So the name, power, and age are actually going to be different for different objects. These variables are what we call non-static variables. When you change them for your first object, you won't change them on your third object. If I change curious over here to something like strong, null in my third object won't change. All these variables, even though they have the same name in your class, all of them in your objects are independent. They're known as non-static variables. And as far as we've seen, this setup of having non-static variables unique to their own objects, work pretty well. Now let's look at the actual implementation of this idea in our program. Now as you can see, I made this class called superhero, which has 3 instance variables, name, power, and age. And I also added setter methods as well as getter methods to set the values for the name, power, and age, and to get the values for the name, power, and age. And this is again similar to that abstract class that I showed you before. Now I also made 3 objects for this superhero class, and these are the same objects that I showed you before. But what I need to do now is actually set values for name, power, and age for all 3 objects. So it's actually called the setter methods for that. And as you can see, I'm calling the setter methods for the 3 variables name, power, and age for all 3 objects. And what's important to notice is that variable can be different values for different objects. There are different copies of that same variable for different objects. Now we do understand what a program is doing. We made a class called superhero, and we made objects or superheroes using that class where I'm storing the name, power, and age of all the superheroes. It's kind of like a database for multiple superheroes. Now let's assume I want to add something else. Let's say I want to find out the total number of good things all superheroes did. That is, across this class and across all the objects that I made using the superhero class, what are the total number of good things they did? Now, this might sound confusing. So, I'll give you another analogy, a very simple one. Let's say you have a class called class, that's your class at school, and the objects are you are a student, and that's an object of that class, and basically you want this variable that counts the total number of students who did a task or who wrote a test or who did an assignment. Basically, I want this variable to be working across multiple objects of the same class. Now, your first instinct referring to the superhero class might be, okay, let's just make an instance variable called private string int good things. And this might seem like it works, but it actually doesn't. So let's actually see why this doesn't work. And to do that, what I'm going to do is I'm going to make this setter method that basically increments to this variable whenever someone does a good thing. It's a simple method. It just says good things is good things plus 1. It's just adding to that because, well, someone did a good thing. That works with what I want to do with this variable. So let's just add that method over here. And it's pretty simple. Whenever an object, basically a superhero, does something good, he or she is going to call this method and it's going to add or it's going to increment good things. The variable good things, by the way. So I'll just increment that. It's really simple. Now, I also want to get a method for this. So what I'm going to do is make another method to just return the value for the variable. So let's just add that method. And as you can see, I have this method now to basically return the value of that variable. So now that we made this method, let's actually call it for the objects that I made. So let's just say obj1 dot increment good things. And what should this do? It should go into this class, take good things, increase it by 1, exactly what I want. And once I add a getter method, obj1 dot get good things, it should return this value. Now to actually display this good things variable, we need to print the get good things method. And that's what we're doing right now. And let's just run this program and we should get 1. And as you can see, I get 1 because I incremented it by 1. And when I print it, I get 1. Now, to show that this indeed works, let's actually copy this and write this variable again. So this is like saying my superhero, object 1, did something good again. So 2 good things. So my method over here should actually print 2 now. And that is indeed what we get. Now I'll change this a little bit more. Now what is this variable doing? It's counting the total number of good things all heroes, that is all objects, did for this class. So if I write obj2 dot increment good things, this should give me 3, right? It should give me 3 according to what I want to do with this variable good things. But I get 2. And this makes sense. Now to understand why that makes sense, let's take a look at our original class again. So as you can see, this is our original class. We have our attributes and our setter and getter methods. And we added another attribute, didn't we? Good things. Now since this good things variable is a non-static variable, all of these 3 objects would store a copy of it and it would look a little like this. Right. So this makes sense till now. Now we'll actually try to see how our program that I just wrote, where I incremented good things, how would that work for this model? So the first thing that we did is we incremented this variable for our first object. And after we do that, we can see that since it's a non-static variable, this good things variable for our first object will change and other objects will remain as 0. Now we also incremented it a second time. So now it will become 2. And then what we did is we incremented that same variable for our second object. So now our second object will become 1. Now this explains the output that we saw in our code editor. In our code editor, I returned the good things variable from our first object. So I get 2. But in reality, I want the sum of the variable in our first object and a second object. The total number of good things done across all of the objects of my superhero class. And clearly, using this good things variable as a non-static variable doesn't help us achieve that, since each of this good things variable will be unique to each object. So what we'll instead do is we'll use what's called the static keyword. So what a static keyword does is, instead of making copies of that same variable for different objects, it makes only one of those variables. So then it would look a little like this. And as you can see, when I use the static keyword for my good things variable, you only have one good things variable, and this is exactly what I want. So now that we removed the specific variables for each object, we have one common variable for all my objects. So if we repeat that same program, and let's say I do increment good things for my first object, you'll notice that good things increases by 1. The variable increases by 1. And so now you'll see something like this. Now I'll call that method again for my first object, which is exactly what we did before. And the variable will again increase by 1. So it will become 2 now. And now we call that method for the second object. But guess what? Now I don't have a specific variable for the second object. I'm using the same variable. So now what will you notice? This will again increase to 3. And that is exactly what we notice. And that is exactly what we want. And how do we actually use this in our program? Well, we use the static keyword. And it's very simple. Now that you understood what exactly the static keyword does, we just put the word static over here. And as you can see, this will just make sure that this variable is universal for all your objects, and you don't have a specific variable for each object. So exactly what I showed you before. So now when I run this program, I should get 3. And as you can see, that's exactly what we get. Now, although using the static keyword in your variables is quite simple, there are a couple of things you need to know when you use them with methods. Now, if you remember the syntax for methods, you would know that the syntax would look something like this. You would have your access specifier, so either public, private, or protected. Then you would have static or non-static. If you watched my video on methods, you should remember this. But till now, we've never used this keyword over here. As you can see, we've always kept it as the access specifier, the return data type, and the name of the method. Now to complete this format, you will have your static or non-static over there. You will have your return data type, void if you're not returning anything. And then you will have your method name. Let's just remove this. So as you can see, there is an option for you to mention if your method is static. But what does that mean? If you look at your static variables, it has some meaning. Basically means that your variables belongs to the class and not to the object. So it is universal, or it is the same variable for all objects. How would that work for a method? Now, there are only 2 rules that you need to know about static methods. A static method can only access static variables. So if you look at all of my instance variables here, all of them are non-static. When you mention the keyword static, then the variable becomes static. But if you don't mention it, it's automatically non-static. So all of my variables are non-static, and I'm accessing the variables in my getter methods or even my setter methods. Now what I'll do is I'll add the static keyword for the get good things method. Now why am I doing this? Because I just told you a static method can only access static variables. So according to that, this should cause an error because good things is clearly non-static over here. Now if I do add the static keyword, you in fact do see an error because, well, this variable is non-static. So what we're going to do is we'll actually add the static keyword for our good things variable and make it a static variable. And now we don't get the same error. So this shows how only a static method can only access a static variable. Now on the other hand, a non-static method can access both static and non-static variables. So that's why if I remove the static keyword, this non-static method is accessing this static variable. It's really simple. A static method can only access a static variable, and the non-static method can access both static and non-static variables. Now the real question is, why do we even have this? Why do we even have static methods? I'll show you something. Generally, when you make an object, you can call methods using that object because that method belongs to that object, right? Now, a static method, like a static variable, doesn't belong to the objects, but it belongs to the class. So in the same way, we were able to change that static variable universally across all my objects. I can access my static method using the class instead of the object. So for instance, I have these objects over here, and usually I could just say obj1 dot get good things, which is again a static method, and this will work. There's no error with this, it's fine. I'll just get that value of good things. But the good things variable belongs to the class. So it makes more sense for me to access this variable from the class. Now that's why we're going to make this a static method, and we'll just make this static. What this means is that this method now belongs to the class. So I can access this method from that class. Instead of saying obj1.getGoodThings, I can just say superhero.get good things. And intuitively as well, this should make sense. My good things variable belongs to my class, and I'm just calling or getting that variable using this method from my class. And again, the only way I can do this is by making this method a static method by adding that static keyword. Now, if this was non-static, let's just remove this, you would see that this doesn't work anymore. I have to call it using that object. So this is the only reason we have the idea of static methods. It makes more sense in your program, and it can access static variables. So the static keyword is really simple to understand, but it can get a little tricky. If you just remember the intuition you learned from this video, you're basically good with it. Now in the next video, we're going to be learning about something called the this keyword. Thank you and have a great day.